All right, so now let's finish up with the trig. So I had asked you to work on some of this on your own. So I hope you filled in from the unit circle these values, because that's how you're then able to draw the sine and cosine curve. Of course, I should have these labeled with radians because calculus is done all in radians. So that's pi over 2, pi, 3 pi over 2, and 2 pi, of course. One thing that I forgot to ask you to do, that I want you to do, is to add a column over here for tangent. Okay, so hopefully you filled this in. If you needed these triangles, a lot of people's high school teachers used to have them use the triangles. Um, Sine and cosine, I really don't care if you write it in this form, right? Radical 2 over 2, or if you just write 1 over radical 2. Okay, either one is totally fine. I don't mind radicals in the bottom, but you probably learned about rationalizing the denominator in high school. So either one of these is a perfectly acceptable way to express sine and cosine. They will be the same at 45 degrees because every 45, 45, 90 triangle is isosceles. Okay, so this is an isosceles triangle, two congruent sides, therefore the hypotenuse and not the hypotenuse, I'm sorry, the adjacent leg and the opposite leg are always going to be the same. So sine and cosine are always going to be the same. And since we know tangent is sine divided by cosine, anything divided by itself is 1. So I had a remedial handout on working with fractions. So let's see if we can divide fractions here to get a value for tangent. Again, I'm not worried about, if you leave a radical in the denominator, I'm okay with that. You do need to have these values memorized. And one thing that I want to point out to you is if you start with sine and you start with 30, look at the pattern that they go in. When you do 30, 45, 60, first of all, everything's over 2. Right? And then if you start with sine of 30, it goes radical 1. We don't put the radical, but radical 1 over 2, radical 2 over 2, radical 3 over 2. Okay, and then it goes back up the other way, radical 1 over 2, radical 2 over 2, radical 3 over 2. Okay, so that's one way you can remember it. So go ahead and fill in, if you need to pause the video, fill in tangent by doing sine divided by cosine. And if you did not find this to be an easy task, if you did not remember how to do the copy, change, flip thing, right? And then these both divide, 2 and 2 divides to 1, and so we get 1 over radical 3. If you wrote 3, wait a minute, I'm sorry, hang on. If you wrote radical 3 over 3, that is the same thing. Either one of these is fine. And then this way would just be this divided by a half. Well, dividing by a half is multiplying by 2. So these 2's would divide to 1, and you would be left with just radical 3. Okay, so then on the next page, you're asked to look at the reciprocal functions. And one of the ways I remember what's the reciprocal of what, so I think it's easy to remember that tan and cotan go together, so to speak. I feel like it would be nicer if like sine, sine starts with an S, if we could say, oh, well, the reciprocal starts with the same letter. But what you have to remember is that the reciprocal, one starts with S and one starts with C, and then they're opposites. Okay, so the trig function and its reciprocal start with opposite letters as far as the C and the S. So that's how I remember them. And all you have to do then is take the values on the page before and flip them over, right? So if you know tan of 60, right, you take that, flip it over, and that's the cotan of 60. So I did give a few values over here to practice with because in that section there were no quadrantal angles, and I would like to practice with some of those. So let's take a minute and try these because the bottom three you need to be looking up at this chart. Okay, so pause the video and try these. Oh, remember, it's possible for something to not be defined, right? Because if I try to take 0, and we can think of it as like 0/1, and I flip 0, I have a problem. I have 0 in the denominator. Okay, so pause the video if you need to and try these. Okay, so here, this is where it's sort of nice to have had it, if you had had it written this way, 1/2, just to flip it and get radical 2. If you had flipped this and had 2/2, again, I'm okay with that. But it's much simpler to write it as radical 2 because if I rationalize this, multiply it by radical 2/2, then you get 2 radical 2/2, the 2's cancel, and you're left with that. Now I go look at cosine at pi/2, and I see that cosine of pi/2 is 0. So that means the reciprocal is undefined. That would tell me that if I were going, I'm going to write UND. If I were going to draw the graph of the secant curve, I'm going to have a vertical asymptote line at pi/2. Now tan is sine over cosine. So sine over cosine, and at 0 cosine, well, cosine's 1, sine's 0, right? So 0 divided by 1, 0 in the numerator is perfectly fine. That's just 0. Okay, so tan of 0 is 0. And then cosecant of 3 pi/2. So 3 pi/2, look at sine. I mean, again, if you thought of that as like -1/1, and then you flip it, right, and get 1/-1, which is all just -1. Okay, then the last thing that I want to do with you involves using reference angles and then talking about just some of the fun stuff that's at the end of this document. For example, we learned the other day that a degree, and we were a bit surprised, I think, that nobody could give me a good definition of degree. It took a while for me to drag that out of anybody. But a degree is 1/360th of a complete rotation. So somebody decided to take the circle and divide the circle up into 360 little pieces, each piece called a degree. Okay, so why, right? Why 360? Like, why not 100? Why not 500? Okay, so there's a couple different theories. Nobody knows for sure. One of them has to do with 360 being divisible by so many numbers because it's really convenient to take our circle and divide it in halves and thirds and quarters and fifths and sixths and eighths and tenths and so on. That's very convenient to be able to do that to our circle. But there is a theory that it has to do with astronomy. I mean, our calendar has 365 days in it, but some of the ancient calendars had an even 300. And so they would notice, now there was a while there that scientists thought that the Earth was the center and the sun went around the Earth, right? Scientists thought that for a long time because we all think we're the center of the universe. It took them a while to realize that the sun is the center and then we revolve around the sun. But they would notice that using astronomy, that it was about 1 degree each day that the Earth was traveling along its elliptical path. And so that circular path would repeat about every 360 days. And so that's another theory on why there's 360 degrees in a circle. So anyway, let's look at the use of reference angles, okay? So in the, let's see, so 120, right? That's this. And if we look at then what the reference angle is to 120, this would be a 60-degree angle right here. Okay, and 240, I get to 240 by continuing another 60 degrees. Okay, so this angle that I just am going to draw here in blue is 240. Okay, so we do know the tangent of 60. Okay, so when we draw here the x and y, so we know that tangent is sine over cosine, so it's y divided by x. Okay, but because of the symmetry, my picture's not great here, but because of the symmetry, right, that's why I had you have those circle cutouts that you could fold in half, and then you could fold top to bottom. This point is exactly the same. It's over x, but the x goes the negative direction, and it's up the same horizontal distance. Okay, so this point is negative xy, and then this point, again, this is the same distance. My picture's not great, but it's the same distance from the y-axis, just this time we go down instead of up. Okay, so if we want to find these values of tan, we know that tangent of 60 is radical 3. Okay, so that's the value of y divided by x, radical 3. So we have the same x and y, right, in both of these angles, but this time one of them's negative. So if one is negative, right, a negative divided by a positive gives us a negative, but then they're both negative, and a negative divided by a negative gives us a positive. Okay, so that's how we use reference angles. And I do show this. Let me just go to the answer key here. So stop sharing that and share the answer key, which is number 21. Oh, so on this answer key, I drew some things you've seen in high school. So you were probably told to memorize certain things in high school, like all students take calculus, right? But, I don't see why you need to have this, learn this acronym. I mean, we know that in the fourth quadrant, X is positive, right? So that would make, if X is positive, X is cosine, so cosine's positive in quadrants 1 and 4, and so on. But notice this is sort of sloppy. This is theta minus 180. Notice when we find reference angles, we either subtract from 180 or do the angle minus 180. We never use 270 in finding reference angles. Okay, so that's something important to note. But again, the use of reference angles all comes from the symmetry of folding the circle in half, either long ways or top to bottom, and whatever coordinates you have here, right? Like if this is 45 degrees, okay, and you have this x and this y, if you come down here, which would be 315 degrees, right? Because if you go 45 degrees down, you'll have this x and this y. Well, the x is still the same, and the y is the same distance. You've moved the same distance down, but you've gone in the downward direction where y is negative. Okay, so that's how we do the problems with reference angles. So please finish those up, and this will become part of your collected homework. And thanks for watching the remote instruction. Have a good long weekend.